Hello, everyone. I'm Luca Niccolini from the Traffic Protocols team at Meta, and I'm going to be the moderator for this panel with the last two speakers. And I'm going to be helped by Barrett behind the scenes. He's collecting questions from the audience. So I'm here with the last two speakers for today, talking about Qwik, and Ian is joining us from Boston, Lucas from London. And on top of working at Google and Cloudflare, Lucas and Ian are two key members of the IETF community. Lucas is a co-chair of the Qwik Working Group, and Ian is the author of many RFCs and drafts. I've had the pleasure of working with them on Qwik and HTTP3, and I'm very happy to be talking to them today. Thanks a lot for your talks, and thanks for being here today. Are you ready for some questions?
Yeah, definitely.
Let's do it then. Lucas, I'm going to start with you. Thank you for your talk about Qwik and HTTP3 in general and Cloudflare's infrastructure. I really liked your Cloudflare dashboard about HTTP3 adoption and how it's growing over time. In general, we usually see with protocols that adoption takes a long time. There's a long tail of clients and server that refrain from upgrading to the cutting edge because it's scary or other reasons. But we know that these clients are missing out on performance. So as a member of the Qwik of the IETF community, what do you think we can do to encourage everyone to upgrade? Is there anything we can do?
That's an excellent question. I've been working on Qwik for a long time, maybe not as long as John has said earlier, like a decade or so. But I think there's a toolbox of transport protocols and HTTP versions that some perform a bit better than others, or address specific problems that might occur in certain parts of the internet, that the way they work. Sometimes on the public internet behaves differently to a data center, and we have the state of implementation is different for one kind of transport protocol to another. This is just a really roundabout way to say that, yes, as the co-chair of the Qwik Working Group, I should be saying, let's deploy it everywhere and get everyone using it. But the reality is that pick the right tool for the job. I don't think we're precious about this, right? There's always going to be a long tail of people who have specific needs, either kind of legislative or policy-based, who just can't upgrade for whatever reasons. And if the internet continues that way, that's fine for them. There's other people who can, enable Qwik and HTTP3 themselves, or they don't have the ability, the technical understanding of how to do that. It's, they're better spent on working on the business side of whatever their internet services are. So they might use a CDN to make, the availability of HTTP3 and Qwik easier. You can just put that in front of your services and turn it on. So then it becomes more of a case of, if you're using such a CDN, have you gone into the dashboard and enabled that feature? It could be supported in your vendor of choice, but maybe you just need to go and turn it on. Maybe you're waiting for some more confidence in numbers like we're seeing now, better stability, better kind of hard real data for other similar businesses like yours that show there are real benefits to this, and so on. I think since Qwik shipped as RFC 9000 last year, like nearly a year ago, or just over a year ago, we've seen, browsers such as Chrome and Firefox enable it by default before then, and this kind of flourishment of more and more HTTP3 being used. Obviously, you have the slight bootstrapping problem that you need to do alt service announcements, kind of advertise the availability. So it's kind of chicken and egg, but we're seeing that being improved upon by things like Service B records or HBS recursive records, like resource records, so that you can just query the DNS and find out about the capabilities of the service you're trying to speak to. So I'm confident that, given another year, that as other browsers start to say enable things by default, maybe command line tools like curl would get confidence and be able to build this in as just a de facto capability that's supported that we'll see more. But it's not a silver bullet. There'll still be cases, in my opinion, where just good old HTTP 1.1 is fine and you're transferring one thing, and TCP is probably going to work, continue to use that. That's okay. HTTP2 is a bit different. We as the IETF and kind of community spent a lot of time designing H2 to solve some problems, and then we shipped it and realized that TCP was still a problem. So for people who really wanted to use the multiplexing and concurrency and kind of the way that that's wrapped up into a connection lifetime and shared lifetimes, I think HB3 is a much better fit for them, especially because of the design differences. It can be a bit more simple to implement, depending on your definition of simple, of course, but that maybe what we'll see over time is kind of bimodal distribution, maybe that some things that are really simple stay with 1.1 and other things naturally gravitate to 3. But who knows? We'll see. Yeah. It's going to be very interesting.
No, thank you for your answer. Well, one thing that makes me hopeful is that it's just a software upgrade. We've seen other upgrades of protocol IPv6 from IPv4 that require hardware upgrades, and so they're expensive and all of that. This, in theory, is just software. Not saying it's easy, but it should be easier. So yeah, thanks for your answer. I want to switch to Ian and ask a question about zero-RTT now. So thanks a lot for your talk, Ian. So what I heard from the talk is that QUIC has a real true zero-RTT, that with TCP it was possible to a certain extent, but it wasn't perfect, and now we have true zero-RTT. So in the constant battle of trying to reduce the handshake latency on the web, QUIC zero-RTT seems the closest we can possibly get to the theoretical limit. Does it mean we're done here? Can we stop working and go home, or where do we go from here? I'm sure there's more good news.
Yeah, that's a great question. The answer, of course, is we're not done. Besides all the fixes and improvements that kind of I tried to outline, and I'm sure there are more things that we didn't uncover yet. There's also kind of non-networking handshake latency. So things like certificate verification can consume a surprising amount of time, and that was kind of uncovered in one of our bugs on the client side in Chrome. There's also things like Jumpstart that were discussed earlier, and congestion control. So there's still a cost to creating a new connection and a new handshake, at least at the moment. And of course, if you're not using QUIC, zero-RTT isn't going to help you. So whether it's advertising QUIC in DNS or being able to persist the alt service record, like all of those things are incredibly important. When you look at kind of timing traces in Chrome net internals or other things, you notice how much time is just spent on other things. And DNS is another one that comes to mind. So there's still a ways to go in getting rid of the rest of the kind of handshake latency that isn't just zero-RTT itself.
Yeah. So my follow-up question would be, are you already working on those next steps?
Yes. Well, we're definitely working on as many as possible. Chrome, as you may know, has a new certificate verifier that's going to be faster. That's been in development for quite a while. And additionally, at least at Google, we're working on rolling out the DNS records that Lucas mentioned earlier, because they definitely increase the rate of QUIC usage and HB3 usage on the public internet, and they seem to work extremely well.
Yeah, thank you. Well, I want to stay with you, Ian, and ask a question about about zero-RTT and all the fixes that you mentioned in the talk, and something that it's implicit with QUIC. There's a lot of like layer merging. We have crypto that is inside the transport now, encryption that is inside the transport, and so I couldn't help but notice that most of the fixes you mentioned in the talk seems to be related to how to juggle these two layers together a little bit. And so in our experience, the code gets complex pretty quickly. And so I wonder if you have any advice for implementers out there for how to deal with this complexity.
Yeah, definitely. I mean, the first piece of advice is that the RFCs, especially 9002 and 9000, do a good job of discussing some of the things that the gotchas you can fall into, as well as some of the suggested optimizations, particularly the congestion control and loss recovery draft 9002. The other thing is that, at least in our case, this was definitely a launch and iterate sort of process where we would find a bug, we would fix it, and sometimes our fix would actually make things worse because it created a new bug, and sometimes our fix would make the problem a little bit better, but not really solve the whole problem because we had actually discovered a whole class of bug, not a particular circumstance. And so a lot of our things were implemented a few times, and now I'm very happy with kind of the code structure for the most part. But I think one has to be willing to kind of launch, iterate, fix, and then after you land 2 or 3 fixes in a given chunk of code, it usually becomes more obvious, like, hey, this is a more generic problem that we need to solve, and not just specific to handshake packets being dropped or a specific encryption type or something like that. But for the most part, we did all this without being aware of the HTTP layer. So we managed to land all the fixes at the transport layer, but they certainly are aware of what is application data, what is initial data, what is handshake data, and what's usually conveyed in all of them. So there is a lot of kind of background knowledge about how the quick handshake really works to land the fixes and optimizations we landed.
Yeah, and in our experience, also working on ZeroTT for Quick at Meta, debuggability and visibility into the transport has been very important to debug this class of problems. And so I have a question for both of you, actually, since in previous talks and the previous panel, we've covered the importance of debuggability and visibility. And Lucas and I actually are collaborating on making QLog standard tool for transport debugging. So I want to start with Lucas first. Can you share any insight or story, if you may, about how you use QLog at Cloudflare? And then
so QLog is it's been adopted by the Quick Working group, but before that, I always had an interest in the fact is, if you're going to write any kind of software implementation, you're probably going to pepper it with some trace logging that at various levels of verbosity you can get an insight into whether things not just going wrong, like an error message or some informational message, but the precise mechanisms are like everything that's happening at every step of the way. These things are useful, but when you try to enable them, maybe for a production service, they'll slow everything down. So typically, I know Facebook has a much bigger scale of these kind of things, but typically you might just enable trace logging to debug specific issues. And Robin Marks, who brought the QLog work to the IETF, went through this whole very detailed history about how they tried to write custom parsers for every quick implementation to try and get insight into what those implementations were doing, how they implemented the Quick protocol. Lots of things in IETF specs are basically implementation choices. Yes, there's requirements that say you must do this or you should do that, but sometimes it's just left up to an implementation to decide what's best for it. Kind of like Ian was saying, it depends on your environment, your constraints, the deployments, the kind of places you're putting that code onto. So keep that in mind. But I was always quite interested in this, and over time, I wanted to develop that capability and put it into the Quiche library, which is Cloudflare's Quiche, not Google Quiche. Don't get that confused. That to have an ability, we do have just boring, straight, right to standard out trace logging, but to also have an option to emit QLogs that could then be ingested into Robin's QViz tool to give us all the benefits of the rendered sequence diagrams or congestion control views to see how we're performing, not just to debug, but to understand better what we're doing. So to that end, kind of what we've evolved through over the last year or two is effectively a standalone Rust crate that implements the QLog data model that could be used by anyone. So I think it's used by Firefox to help them do some QLog, but we use it too. And for the longest time, it was only for serialization, so writing things out. But within some of the updates that have happened to those drafts over the last few, say, 6 months, I was able to refactor that code to let me deserialize it. So writing complementary tools to QViz to let me analyze the logs that I've got to kind of deep dive into some specific things I've been trying to look at. So we do use QLog. Other engineers, as well as myself, have used it extensively in terms of like time and scope of things we've investigated to help us analyze what's happening and to try and track things down. So we're very grateful to all the contributors for the specs and the tooling that's out there. And maybe at some point we can maybe try and contribute back some of our deserialization and analysis tooling back to the community to see if they value it as much as us. It's hard sometimes because you create kind of bespoke or custom tools to help you analyze one specific kind of issue or bug, and then beyond that, it's probably useless to other people. But you just never know.
Yeah. No, thanks a lot. And there is a follow-up question from the audience actually that is like, well, this protocol debugging being more approachable. One could argue that developers just want to use APIs on top of the transport. Why should they care that it's like more debuggable?
I'll respond to that one as well while I've got the mic and it's open. I think it's a good question. It depends what we mean by developers. So the point of my talk was trying to talk not just at internet scale of delivering bits and bytes, but human scale. There's many stacks of people who are involved with the internet, whether you're just designing a web page in a CMS and you don't care, you don't even know what HTTP is. That's a fine position to be a very big contributor to the web and technology. Sometimes you're people like us who get to spend a lot of time thinking about the protocol and the transport layer and wanting to design some new work and investigate how that works or doesn't work. But there's a whole community of other people who want to make use of these new protocols and understand how they actually work. So a good example would be like Chrome DevTools, which can give you a waterfall view of how a web page load worked. And it's pretty good, but there's always information that's not in that view. And you will need to dive into like the net logs to see it. And there's a net logs viewer, which is very surface level, and it lets you kind of scroll through the net logs. And that's okay if you're trying to look for something. It can show you that a problem or an issue happened. And that's good. Like we get people send them to us to try and investigate issues. And somewhere in between, you've got something like web page test, which can capture the net log and then use that information to render its own waterfall with more information. And that kind of view was very useful for HTTP2 prioritization to show you how servers in the wild, having seen web page requests from different kind of browsers, actually sent those bytes back. And that can be very important for the web performance community to understand, you have a million different variables to control on a web page. You need to know how they interact with each other. So I think there's a place like, why not make that data available? If people don't choose to use it, that's okay, but at least it's there. My problem right now is it's very opaque and it's hard to get to. So, I believe in kind of the right to repair, if something's broken and you're a competent person who's technically minded and could maybe investigate, find the problem and maybe even fix it, given we've got so much open source code in the world, but you don't even know where to start looking why the problem occurred. That's a bad place for everybody in the world, in my opinion.
Or just collect a trace and share it with who can debug it for you. Thanks a lot, Lucas. Ian, very briefly, do you use Qlog to debug? Did you use Qlog to debug zero-RTT?
I've used it a few times. There is a netinternals or netlog, Chrome netlog to Qlog sort of converter that I've used a few times, and it's I really enjoy using Qlog. But most of the time, I actually look at netinternals sort of in the encoded version, kind of in the raw version, and look for issues. But the most useful tool we actually have is server-side logging, which we have at scale. And it's sampled, but we can look for specific issues that we're looking for, whether it's high retransmit rates or a certain quick connection close reason or flow control blockage, like all of these issues. And so if we have an issue that we think is quite rare, we can look through many, many traces and many, many flows to try to find the key ones that might characterize the issue. And then we subsequently have some more TCP style tracing, as well as kind of a very raw view to try to look through exactly what packets were sent, what types of frames were in them, so on and so forth. It's very much like a netlog sort of format, but we have a visualization for it. And that was critical to solving a ton of the issues we have. But yeah, I look forward to adopting QLog at some point, but our format preceded it. So it's always hard to unseat the incumbent.
We're working on it. Well, it will happen soon. A couple more questions for you, Ian, about ZeroRTT. So from the presentation, it seems like, and in general, ZeroRTT's design seems to be designed for when a client wants to send data before the handshake is completed, or like when it's completed with ZeroRTT. What if the server actually wants to send data as early as possible? I know you mentioned it briefly, but
yeah. So there's something that in TLS 1.3 is called half RTT data, and that's the server using the full 1RTT keys to send data to the client, and that works for all TLS 1.3 handshakes, pretty much on the first server response. And it doesn't have any of the replay issues or other issues that ZeroRTT might have in restrictions. And so even without resumption, you can use half RTT data. So it actually makes TLS 1.3 over QUIC a particularly ideal solution for the server speaks first. The one thing I will add that was mentioned in the ZeroRTT talk is token-based address validation is still very important if you're going to send any reasonable amount of data in a server speaks first sort of protocol.
Okay, and any security implications from using ZeroRTT or half RTT that you can?
Yeah, so there really aren't any security implications on top of regular TLS resumption, but there is a replay concern, which I kind of alluded to a moment ago, where there are ways to get ZeroRTT packets to be replayed against multiple servers. And if you were sending a request, say that, deposited $100 in someone's bank account, and you replayed that, many, many times, someone could be either very happy or very sad. And so requests that are clearly not idempotent really should not be sent over ZeroRTT. And in particular, the IETF specifications say you can only send idempotent methods like GET and head over ZeroRTT. That being said, a lot of browsers and client implementations already do replay at various levels in the stack. And so a lot of applications kind of have to deal with replay, even for things like Post, because of the different levels of replay that exist on the internet. So,
yeah, thanks a lot. And we're at time. Our 20 minutes are over. Thanks a lot for your presentation and for being here live for the Q&A. And this was a pleasure. Thanks, Lucas. Thanks, Ian. Looking forward to meet you soon in person.
Thank you very much,
Looking forward to
Luca.
it too.